It's the chair's great privilege to call Lois Snary to the stand. I can't believe your own daughter made you wait this long in the day to testify before my committee.
Mr. Chairman, I'm just real proud to be here any time you call me.
Yeah.
Mr. Chairman and committee members, I want to first echo or continue on some of the comments that were made by Chairman Sadler, and thank all of you for having the initiative and taking the initiative and having the leadership to look at this very critical issue for all of us in the state of Texas, and then also for taking time away from your businesses and your families to be here in Austin while you do that. I'm Lois Snary. I'm with Gulf Coast Green Energy. Mr. Chairman, you were talking earlier about your committee looking at the 30,000-foot view, and I'd like to give you kind of an overview of another sector of the energy industry that we've not really discussed much here today yet, and that is waste heat. What we know about waste heat is that there's over 9 million megawatts of energy worldwide in waste heat. Now, what that translates into is 18,500 megawatt coal-fired plants. 18,000. That's how much waste heat is there for recapture to be able to generate electricity with. The fact is, waste heat is bigger than oil, coal, natural gas, and nuclear power all combined, because 50 to 60% of all manufacturing, of all things that are created in this world, 50 to 60% of that is in the form of waste heat. It is truly a zero pollution energy. There's zero pollution, zero emissions, and it is free energy there for the taking. The fact is, the fuel to create it is already paid for. It's already consumed, and most of it's going up in the stack. I was up in another state yesterday taking a look at some of that waste heat that was going up the stack. If we could recover, now obviously we're not going to be able to recover all of that waste heat that I spoke of earlier, but what if we could recover just 5% of it? What that would generate would be 380,000 megawatts of power from waste heat. That translates into, arguably, at a rate of 8 to 9 cents a kilowatt hour, about $350 billion each year. And when I've tried to relate what does that mean, that translates into the energy markets could support in waste heat, with only capturing 5% of it. 2,300 companies, 2,300, $150 million a year companies. So that's what we have at stake here in the state of Texas and in this country. Actually, there's really no catch to it. Waste heat energy recovers, and conservation is going to grow simply because it's just simple. It's compelling reasons to do that. It's waste heat that's free, and it's zero emissions. Gulf Coast Green Energy, the company that I'm with, I'd like to visit with you just a moment about that and tell you how we capture waste heat to generate electricity. I would urge this committee and the legislature in this next session, Mr. Chairman, to include waste heat in the renewable credits for non-wind. We think that it would be very appropriate to do that. I have included in your packet there, just to tell you how I have it organized, there's 2 pages in there that have 8 slides from an overall PowerPoint presentation, which is also in your packet, that you or your staff members may want to take a look at another time. But just as an overview here today, I just want to let you know that Gulf Coast Green Energy is a new startup company. It's located in Matagorda County, Texas, and we're proud of that. We are a startup company. We are the exclusive distributors for a brand new technology that was developed actually at City University in London, England, and was licensed to Electrotherm, is the name of the company, in Carson City, Nevada. And we're the exclusive distributors for that technology here in the state of Texas. Our technology makes electricity from the heat sources that you'll find there on one of your slides. Distributed generation, that's the cogen plants, those big, huge diesel generators. We can tap into the water jacket on that, run it through our equipment, generate electricity, and we can also capture waste heat from the exhaust on those engines also. Coal-fired plants, I'm working with 2 municipally owned power plants here in the state of Texas, and we've identified enough heat in one of those, waste heat, and one of those power plants to generate about another 1 to 1.5 megawatts in that power plant. Hydrothermal and geothermal sources, you heard Dr. Erdlach and others talk about that here today, and we're working with the geothermal lab at SMU. Southern Methodist University has an internationally known geothermal lab there, and we're working with those folks to identify some of the sources that Dr. Erdlach was talking about earlier today. And all of those are also related to the oil and gas wells. You'll see on your next slide there that that is an example of a 500 megawatt coal plant. Some interesting numbers there. The members of this committee are probably aware of all those, but I can tell you it was enlightening for me. I've been with this company about 6 months now, but just taking a look at the number of tons of coal that one of those 500 megawatt power plants burns every year, and that's almost 1.5 million tons of coal. What we can do, what we are convinced that our technology can do, is go into those coal-fired plants, utilizing the waste heat from those coal-fired plants, and generate another 10% electricity. Now that is zero emissions, zero additional fuel. What we call it is making something from nothing, basically. The fuel's already been spent, and we can utilize those waste heat sources to generate that electricity. It's actually for the coal industry, and thankfully we've got coal-fired power plants so that we can turn these lights on when we come into the rooms and all the other things that we depend on them for. But our technology doesn't clean up the air, but we can reduce the overall emissions by generating additional electricity with the same amount of coal. You'll see your next slide there. It's a very simple system. Ours is an organic Rankine cycle system. We basically use a heat exchanger. Mr. Chairman, you and I understand a heat exchanger is nothing more than a radiator like on a tractor. And we run the heat source through that radiator, and then we take our refrigerant, run it through that heat exchanger. That's excited, and then different from other technologies that are on the market, we use an expander, a twin screw expander, rather than a turbine. It allows us, your next slide will let you know the advantages that we have there, because we turn at 1/10 the speed of a turbo expander. We can operate in a wet environment, so that means we don't have to have a lubricant to take care of our equipment. And then the next slide there talks about just the cost of the equipment. The good news for the industry is that this equipment has a return on investment of about 3 years or less, more or less. The next slide talks about the applications where we can utilize this technology, and that gives the minimum heat and heat sources there. And then in conclusion, our power systems recycle recoverable energy to make electricity. We use no additional fuel. It's emissions free. We think that it is green energy because we're actually making something from nothing. When you talk to the folks that, as Dr. Erdlach did, and just think about the oil and gas industry, we can hook our equipment up to those oil and gas wells that Dr. Erdlach was talking about and generate electricity right out there in the oil patch. For the folks who are making the investment, for those exploration companies, those making those investments in that, to be able to know that at the end of the line, when that well plays out, that they can then start generating electricity, it has huge implications. Our crew is at the campus of Southern Methodist University today. They're going to flip the switch on the 50 kilowatt unit. This technology is so new that serial number on that unit is 0001. And so we're real proud that the state of Texas is the state that first piece of equipment is going to be fired up in. I was, as I said, at some military installations yesterday in other parts of the country that we'll be able to utilize incinerators where they're actually burning municipal waste on those military installations for the cities. And it's the really neat part of that is that they're burning that waste rather than taking it to a landfill. It's going to extend the life of those landfills by about 300 years, and we'll use the heat from that burned waste in those incinerators to heat the water to run through the equipment and generate electricity. So in keeping with your request to keep this to 5 minutes or so, Mr. Chairman, I conclude my remarks, but would look for any questions that you may have.
Are there any questions, members? You know, it's too simple to be true. So it's bound to work.
Yes, sir.
Yeah. I'm just sorry it wasn't a Texas idea to start with.
Well, but Texas got here just as quick as we could.
Yeah, I understand. Lloyd, thank you.
Yes, sir. Thank you, Mr. Chairman.